Damien, are you giving this class?
Yeah, it's gonna be me. I'm just gonna wait a little bit, see who else is gonna join us.
Yeah, I think Yana was just wrapping up. She kind of went a little long, so there might be some people jumping over from that one.
Yeah, I heard it was like another one for the PMs too.
Before that though.
Yeah.
That one ended early, so they were good.
Oh.
Might have been something else though. I don't know. There might have been another PM thing.
Hello.
Hello.
I don't think so, Steve. I think it was just that one.
Okay.
All right, I'm gonna wait like till the 5 and then I'll begin.
Don't you have like a joke or something you start out with, like an icebreaker?
We should. I didn't have anything prepared. What do you
I don't know. I just now you put me on the spot. I have no idea.
What do you call a fly without wings?
Oh.
Oh,
What?
here we go.
What do you call a fly without wings?
I have no idea.
A walk.
Oh wow.
It's the stupidest joke, but it makes me laugh so much. What do you call a cow without legs?
What?
Ground ground beef.
Good Lord.
Oh, here we go with the jokes.
Oh my God. Okay, I'm done.
I missed the joke.
That's pretty good.
That was good. That was good. Let's see who's in here. There it is. All right, well, I'm gonna get started. If people join, they'll join when the good part begins anyways. Let me, I'm gonna introduce myself. Well, I'm Damien. I work with the sales team in the Fremont office. And I'm gonna show you just a little overview of what we do. Basically, what I do, Farsad and Daniel. Just a little bit about the sales modeling, and then what we use it for, and then what we're trying to move forward from what we have so far. Okay, so basically, the sales model purpose. So the purpose of this is to provide a customer with a more accurate estimate, faster turnaround time, and a lighter bin file, and also provide them with the visual aid that has our Walt systems. So the biggest one of this is that we want to be as accurate as possible. So this actually helps us a lot because we are able to build the whole building in a quicker, faster way, but also be very accurate when we have because we have our you know, our parts there and included already, so we can actually get the most accurate numbers for those when we do the takeoff. Also, is a faster turnaround time, since it's a simpler way to build a building on Revit. It takes us up to, sometimes it's quicker. Some buildings are quicker than others, but it's a quicker way to build these. And it's also lighter, so it's a lot smaller because the shapes are just overall like the overall shape of the parts, but we don't necessarily have each detail on those parts embedded, except for you know, a cutoff of the views of the details. Also, like I said, it's a good visual aid because we are giving the customer with what the closest that it's going to look like once it goes through shop drawings and they actually create the walls for us. Some of the sales model uses that I've done is we do this to provide a help to the estimators with budgets and hard bids. The differences between these two, usually budgets actually right now for Saad and myself are working in one of them for Flower Mart. So it's basically they usually just want to know what the price will be. So they just care about the square footage per system. They want to know about you know, the glass and how much square footage that's going to be, the metal, and then all the metal panels and all that stuff. So they kind of just want a raw number. So we don't really care about too much we don't really dive into the detail too much. And then the next one will be hard bids. This is when the one example that I'm gonna be showing you. This is when we are bidding for the project. The architect already has most of the design calculated. They already kind of know what the overall idea of the building is already there. So this is almost finalized by them. This is the one that we're trying to aim to be better, just because we want to get those jobs. We want to be as accurate as possible and show them like that we are capable of giving them a good quality product from the beginning, not just at the end of this. And this leads to the sales modeling process. So basically, this is the process that we follow for the sales model. So first, the estimator files the sales model request form, and then Gabriel sets up a kickoff meeting with the party involved. Usually involves a PM, the estimators. Then we have myself or whoever else is working on it, Gabriel, and then we have the whole sales team in there, Amy. And then also we're trying to incorporate Jumpstart, whoever is working on those details, because we want to be able to work together from that moment. And like Sahar was mentioning the other day, she be able to identify problems ahead of time that we can easily fix later if we find those early. Then the next thing we do is document analysis. This is where we go dig deep into the drawings and we make sure that we are checking every elevation and for you know any frames that we might need to produce or any frames that we already have in there. So I'll show you right now an example. I'm just gonna go over the steps. And then the next step is to frame production. So this is where we identify all the frames that we have, and then we identify the frames that we still need to create. And this is where we have our sales team create these frames if necessary, and then we can continue to model. And so with that, I'm gonna show you just a little quick example. Let me go here. So let's see. So this is gonna be, I'm gonna show you 100 Altair. This was a hard bid, basically a hard bid, but the project's already ours. So here's the 100 Altair 100% DD. So this is where we go and basically go elevation by elevation, and then we identify the different units that we have. So for example, here is one that I marked up. So we identify where we think the stack joint will be, and then we cross the units, and then we call them these names. This makes no sense unless I explain. So this is 3 light stack over opening. So we have a stack joint up here, and then we have an opening down here. And then this is a 1, 2, 3 light. So that's basically what we do. There's another one here. So 2 lights stack over stack. So basically there's a stack joint up there, stack joint down here. And then we have a 2 lights, so 1 and 2. And then we also, go around the whole building and then try to find as many as possible as we can. We're probably not gonna finish all of them. We probably are gonna identify some later on once we dig in and start modeling. And an example was this one right here. This one was at first, the first sight, I thought this was a separate light, but then once I dug into the proposal drawings, and I found out this is actually a kiss mullion. So I went ahead and put this 3 light opening. So there's an opening up here and then a stack down here with the kiss mullion, and then I set the attachment. So basically I try to, since this is not a very typical one, so this is not a typical frame, I try to include attachments of the architect's profile, section view. So it shows you right there that there's a little kiss mullion right there, and this light runs through. So basically, this is what I mean by a document analysis. So we do the same with all the other elevations. Here I skip them because it kind of repeats the same type of frames around. So I didn't want to continue, and instead what I did, I just start modeling, which is what I'm going to show you next right here. So this is 100 Altair, and this is after I finished basically modeling the entire building with the sales model frames. And it's pretty simple what the way we do it, because it's like I said, it's a basic wall that has basic geometry, just pretty much the profiles view of each of the parts. It doesn't have that much detail. If you were to cut it, you can see that there's something there. That's because we incorporate on the frames an image of the detail, how it's gonna look. But the geometry itself, it doesn't really do all those little holes in it. So what I usually do here is, once I like Gabriel showed last week, he showed us how to set up the project. Once that whole process is done and we have all the, we acquire the coordinates and we have the model linked in over here, we're ready to model, then what I do, I usually just draw myself my reference planes where my walls are gonna go, and then I just go ahead and draw a wall. I'm just gonna show you one real quick. And I know this one, but it's a strip window, so I'm gonna go change it here to the strip window. This is important because you wanna differentiate your different types of windows, because later when you run the Takeoff program, you want to be able to separate those the current wall from the strip window and the punch openings, so you can give different results to your estimator. So here I go and I draw my first wall. And I just go all the way over here, and I know that the way the details are, my mullion is supposed to be at the edge. The edge of the mullion is supposed to be lined up with this right here. So I already made that this reference plane to do that for me. So there I have it. This is my wall. So now I'm gonna just include the frame now, the frame that I already loaded. So this one was a 2 light opening over opening, and I'm gonna do this is another thing. So the CII basically is saying, like, we have capture, head, invisal, intermediate horizontal, and then invisal still. These are all the different types. So we have all invisals and all captures. For this case, we have a capture head, and then the rest are invisal. So I'm gonna click this one. And there it is. So now we have, you can see right here, this is the image that I was talking about. It looks like the part's there, but it really isn't. It's just an image that we have. Then basically what I do here is just go and cut this apart to create each of the individual units. And there it is, last one. And basically you can see right here, we have both of the intermediate verticals on each of the unit. I can go ahead and change these right here. For example, this one, it's gonna be an outside corner, so I can go change this to be a 2L. We're opening OC. Here's the outside corner, and then we just find this is gonna be on the right side. So we're gonna do this one right here. And you can see right there that we have the corner. And I'm gonna turn off now that left one. I mean, I'm sorry, the right one. And there's that part right there. And then we go to this edge over here. And then now I'm gonna put a jam there. And all I gotta do is just turn off the left Inviso and then turn on the Inviso jam left. And you're gonna see it change. And there it is. And I have it lined up like my details show. Then just to double check, I go here and then I create a section just to check that my horizontal is in the right spot and then that my head is in the right spot. And you see it's not, it's way up there. You can see the heads right here. So I have my reference plane and I have to just account for the cock joints. So I'm gonna go ahead and click that. I have a 1-inch cock joint, and just because of the time, I don't have much time to show it. But basically, I do have to go through each of the details of proposal drawings or the jumpstart package that you have, and make sure that you are, putting the right cock joints. Then basically, I'm just gonna draw it there. Take a little more because so it's basically doing the whole wall. I'm gonna do a elevation view so you see. All right, so now I can see that my horizontal is not in the right way. So here I can measure and see that I am 6'4.5" off. So I'm gonna just add that here plus 6'4.5" inches. Let's see, so that's a 3 and then that's equal. There you go. And there it is. Now I have it on the right spot. Oops. There it is. And now I'm gonna do an elevation view here. And you'll see, since I had already cut here it is. Since I already cut the units apart, it only made the change where I had the section. So I usually just do match properties and that's done. There it is. And there it is. So basically now we have the wall. If you were to cut a detail view here, you will see each of the parts. But like I said, I don't have a time to explain the frames, but the frames are basically just gonna be the outside shape of it. It doesn't have anything it doesn't have all these little holes cut out. It's just a picture, but you can see each of the parts here and it looks pretty cool. So like, it looks like it's finished, but so yeah, that we basically go through the whole building and that's how all of this is built up. We also have some parts where, all the frames have a chance for you to include the sunshades and the parapets, and we have parapets right here. So we have different frames. We have also, here's a parapet frame, and we also have soffit frames, for example, right here, that we use for soffits. And that's how everything's created. We just create a wall, and then we just include whatever frame that we want to put in there. Yeah, and then once the whole building is completed, and that's when the second part of our system begins. But does anybody have any questions so far? All right. Okay. All right. So the last part of this is basically when we do the sales takeoff process, and this is a process that is important because this is where we get the data that we will be showing our customer. This is where the numbers come out. So we want to be very careful. So the first step that we do is we want to verify the entire building by using the Takeoff browser. So what that means is that Takeoff browser that you have in Revit, you basically use it to double check that you have the right parts. That you have called out the right elevations and all that. Then I'm going to show you that real quick right here. So basically, since this is a hard bid, I care about having the right parts and the right aliases in there. So I use the Takeoff browser that we have over here on the Takeoff and then Takeoff browser. I want to make sure that all these VLI, JRI, what each one of these are. This is the alias of vertical left in Viso, and then jam right in Viso, and these are all the different aliases that we have for the parts. So we want to make sure that we have the right ones. For example, like right here, we have a parapet. So we want to make sure that the alias is that says that. So this one is HPC. That means head parapet capture. So this is good to go. So basically, we go through each one of these aliases, and then we want to associate those with the details. So let me go ahead and for that HPC, let's go right here. So we have that this 10608 is assigned there. So we go check it, and then okay, so this is a head capture and then has a parapet. So this must be an HPC. So we say this is HPC. And this is important to assign match the right aliases with the right details, because this is where we're gonna come and double check that we have the right parts in our takeoff program. So it knows what to read when we run the program. Yeah, so we go through each one of these aliases, and then we match them with each one of these different details and double check the parts. So yeah, that takes us to the last little bit of it, which is just that's when we let the machines work. We do a little bit of pre-work ourselves. This is where we start the project on the Takeoff program. We basically include the information of the project. We edit the framing systems. Basically, that's where we say, okay, we're gonna we have tech wall, we have W75 or any other system, and we identify it there. That's where we put all the parts and all that stuff that are missing. We run UPDs to update that information into our Takeoff program, and then we also go and tell the Takeoff program which areas we want to be calculated. So it can calculate all of them, or if we want to get specifics. For example, for this example today, I just did the current wall for that building because we have punch openings and strip windows, and we have guardrail, and we have soffit and all the things. But yeah, so basically we tell the program we want you to read just a current wall, or basically tell them what to do. And the last thing is the elevation information. That's where we tell the program, okay, so for those areas that we told you to read, to calculate, I want you to assign these systems into those areas only. So what it does is basically driven by the aliases that we assign to those parts in the Revit. It reads it off the parts that the aliases that we have in our. Everything's gonna make sense once I show you. It's gonna read it off the program, and then that's how we can optimize the extrusions. Basically, gives us all the sizes for the parts. And so let me give you a little show and tell. Okay. So here's this is what the Takeoff program looks like. If you guys haven't seen it yet, basically we create a new project, and this is where we enter the project information. We basically put the name and the job number so it knows what to look for. And then we go down to the framing systems, and this is where those aliases are important, because we can see right here HPC, head parapet captured. Let's see. So we want to make sure that HPC has those parts in here. And I can see that I have 3170 and then 3203, and then I have the gaskets and all the other little parts. But we mostly care about, you know, the parts, the W75 parts. I tend to write the gaskets as well, but doesn't really do much for us at this point. So you can see right here. So I have the W75 3170, and you can see a little preview. And then we have the 3203. So basically, yes, this checks out. So I go and put the checks there, and that's done. So that is how we edit the framing systems. Once we go through each one of these aliases, we go through all the parts, all the proposal drawings that we had, or the Jumpstart package 3. That's when we are able to run UPD, and this will allow us to the Takeoff program to read those aliases and match them with the ones that we put in the Takeoff program. All right, and then also this is where we tell the program, okay, we want this area. For example, right here I have current wall. So we say the area and what group does it pertain, and we just put current wall. So this is where we tell them, okay, I want you to calculate this areas, guardrail, punch openings, soffits, and strip windows, and any other. You can also do all of them at the same time. You can do on all systems. And then the last thing you can do here is the elevation information. This is where you tell the program, okay, I already told you which areas I want you to calculate. Now I want you to assign that system that I created for you. So 100 altered W75 system. This is the system that I created, putting each one of the W75 parts, the aliases matched with the ones from Revit and the ones from the program. So once that happens, then we allow optimized extrusions. And what it does is basically this generates all the part sizes, the lengths, and automatically does it for you. I'm not gonna run it because it takes a little long, but this is the end of it. This is basically where if you get no errors, you're done. You export the data to Excel, and it looks something like this once you export it. So basically right here, we have the extrusions. This is all taken from there. So it reads all the parts, and then it shows you the quantities, the lengths, and also the die numbers, and then all the prices. If you add a little more over here, you get more data. But this is the end result basically that we have. So this is what helps the estimators estimate their numbers. But one of the new things that we are trying to do is the use of schedules to extract new data. This is something new that the sales team has been working on. And basically what it is so it's a preset schedule that I believe Amy worked on. And these are actually very useful. one of the schedules that I'm going to show you is going to be this one. I have it open. Glass sizes. So for example, for this one, I have metal panels, walls, so they're stainless steel or whatever. I guess I assigned that one to that. That had vision glass. So basically, what we're trying to do in the future is move away from these Excel sheets and stick with the schedules so use the full power that Revit has. And you can do many things. For example, I have handrail right here. It shows you the linear footage and the square footage, and also like if I were to assign a material to that, it'll tell you right there. You can do the vents if you had any, the doors. It shows that there's 3 doors, and then it shows you the type of doors. Back pans if I had any in there. Basically, this can be done for many different things. Here's the total square footage per system. So we have curtain wall, guardrail, punch opening, soffit, and strip window. And apparently some of this that I didn't assign, and I believe this is the panel wall that I didn't assign anything to. But yes, that's basically the whole thing. That's the whole process for the cells modeling. I don't know if anybody has any questions.
I was wondering, right now we use the sales model for reference when it goes over to the drafting side.
Mm-hmm.
At some point, are we going to be able to use this and just build off of this versus redoing it over on the drafting side?
I think that was the goal that we were aiming for. It's just there was a misconnection between the Takeoff program and Amy units, but I think they're working things out. For example, one of the things that I was talking with about this was the parapet. The Takeoff program wasn't reading all the entire thing, and we're kind of like maneuvering things around to make it read the faces of that, so we can actually use Amy units. So yeah, the end goal is just to go from this sales model and then just kind of create the shop drawings. So be able to have those, yeah, like you said, reuse this.
Very cool.
Right now, Damien, how the schedules you're producing, the new ones that Amy's putting together, how does that data get into the estimates?
Oh, so yeah, I didn't show you that because it's still kind of like a little effy, but so basically there's let me show you real quick. Yeah, where is it at? Takeoff. Yeah, we're trying to I've done it a couple of times. There's a dynamo routine that Amy produced. And basically what it does is it takes this data that you see here, like the schedules, and puts it into an Excel sheet. So it gives us, oh, let me actually open one here. So here's, so this is what Amy has been working on. So basically all those schedules get transferred and put into one Excel sheet using a dynamo routine that she created. And that's, oh, it's right here, managed. So it's a super easy one. I love it. It's just literally one click, and like right here. As long as I have that Excel sheet saved with in that folder, and then I run this, and it imports all the schedules into that one page. So you don't have to be digging through each one of the schedules. You have one page that you can just, have it in one place. Yeah. So that's the other thing that with testing still. But we've done it. I've done it like twice, I think, for like 2 projects.
Yeah, so currently we'll run this, and then we'll just provide that Excel sheet to the estimator, and then they'll take from that whatever they need to put it in their estimates. That's how we're actually doing it now. So we'll give them the sales template with the extrusion data and the glass. We'll give them this Excel sheet, which has all those different tabs at the bottom. and then we'll provide both of them to them, and they're the ones who actually determine, putting it in the actual screen sheets.
Okay.
Mhm. Yeah.
Well, great job walking us through it.
Thank you. Hopefully this
Very cool.
kind of answers some of the questions, and hopefully this we can move forward with this even more.
Mhm.
We've done so far.
Yeah, really, really cool stuff.
Yeah, we're getting there. Looking
Yeah.
good.
I know,
Thank
think
you.
about like 3 years ago.
I know, right? Exactly.
Yeah, we've moved a lot since I started working here. It's been 2 years, 2.5 years. I don't know, 2 and something.
And Lisa, they will tie together eventually. We're working on a few things to kind of bring that all together. So
Yeah, that would be good. Got to work out the kinks first, though. That's for sure.
yeah, and it was one of those things where, you needed to be able to kind of move quickly. As you can see, there's a lot of data to get the sales group and things like that. And so we wanted that to sort of be able to move forward without being, hampered by a whole lot of development cycles. So
Mhm.
lets them kind of get their thing done and get it going and get sales used to it. And there's a couple things we're working on. One is tying this into how we get the data into the portal. So the estimates are all just in the portal, they're not in Excel. And then the other thing is to get this to kind of work downstream so we can get it to go together. So
Nice.
Mhm. All right, that's all from me. If you guys don't have any questions, then that's it.
nice job, brother.
Thank you.
Thank you.
Thanks, Dave.
Thank you.
Thanks, Amy.
Thank you, guys.
Thank
Thank you.